Okay, let's go ahead and get started on section 1.4, solving equations. If you could go ahead and read this problem. This is a problem that comes up sometimes when you are working with models and artwork. They're asking you to find out what the weight of each shape is, and you can create a specific equation for that. We'll get into that a little bit more often later on. Here are your objectives for your Cornell notes. Here and here. To solve equations and to solve problems by writing equations. Let's take a look at some of the properties that you might want to put down again in your Cornell notes. Reflexive. That A equals A, 5 equals 5. This equal sign means that both sides are the same, and they're reflecting the values. Symmetric. If A equals B, then B equals A. Transitive. If A equals B and B equals C, then A equals C. This means that you transitioned from A to B, from B to C, and were able to relate A to C. Substitution. If A equals B, then you can replace A and B with, or vice versa. And here's an example of that. Let's take a look at solving one-step equations. The trick is to keep your equation balanced. So here we want to get x by itself. So we're going to have to do the opposite operation. And that's going to be negative 12 minus another 4, negative 16. Same thing here. Do the opposite operation. The opposite of multiplication is division. Twelve goes into 12 once, so simplify to 1. And we're going to have b equals 18 twelfths. Yes, I want you to reduce your fractions. So simplify this by how many times 6 goes in here? It's going to be 3 and 2. And that's how I want these simplified fractions to look like. Let's move on to multiple step equations. Similar to the one-step equations, but you're just doing more than one. Let's take a look at this first side parentheses. We're going to have to go ahead and distribute. Get all the y's on one side. All the constants on the other. And do the opposite operation. Same here. And if you noticed, I distribute here and here, here and here. Combine like terms. 5 by 11. Let's clear this up a bit. I want you to try these two right here. Let's take a look at this word problem. Go ahead and take a few seconds to go ahead and read this, and then we'll solve it here in a second. So if you take a look at this, you can see a couple important things. One, perimeter is 200 meters. This side is 3x, and this side is x. So if we're looking at perimeter, this side here is going to be x also, and this side here is also going to be 3x. So let's add up all the sides. So they total 200. Remember, you have 3x's here, 3x's here, and x here, and x here, for a total of 8x's. And 8 goes into 20. 25 times. Therefore, this side is going to be 25. This side is going to be 25. And since this is 3 times as long, it's going to be 75 here and 75 here. We've got a nice little definition right here that you might want to put in your Cornell notes for sure. Basically, all this discussion of equations is that you have 3 different types, or as I'll say, 3 different flavors of solutions. You can always have a solution, sometimes have a solution, or never have a solution. If you have an equation where it's always true for every value, they call that the identity. Let's take a look at an example here. Let's solve this one and see what happens. Let's combine like terms on this side. And as you can tell, it looks as if the equations are the same on both sides, just there's been a bit of commutative property here. So let's just suppose we subtract 4x from both sides. And you're going to have 5 equals 5. This is going to be always true. No matter what you put in for x, it's always going to be true. Let's take a look at another situation. Here, let's again combine like terms on both sides. Combine like terms on both sides. Subtract 3x from both sides. And you're going to be left with 4 equals 5. We know this is not true, therefore this is never true. So now what I want you to do is to go ahead and try both of these on your Cornell notes. Let's talk about solving literal equations. In other words, we're looking to write equations in a specific way. Take a look at our first problem. This is the equation for temperatures, for converting Fahrenheit to Celsius. And what they want to do is they want to get this in terms of C to show what F is. So in other words, what is F means that we're going to try and solve for F. Oops. So let's first distribute, or excuse me, write the equation. Now the craziest part about this equation is this F, or excuse me, this 5/9. Well, one thing we learned in the last section is that if we multiply things by the reciprocal, they become 1. So wouldn't it be nice if this was 1? Well, the way to do that is to multiply by the reciprocal of 5/9. So here's our reciprocal for 9/5. Multiply that on both sides. 9/5, 9/5. This is going to simplify to 1. And then all I need to do is add 32 to both sides. And you solve for F. Next one, very simple. Solve for C. Subtract. Let's take a look at one a little bit more involved. Here we want to get b sub 2 by itself, this one right here. So what we're going to do is get rid of this fraction first. The reciprocal of 1/2 is 2/1. Simplify. Opposite operation, divide by h. Then subtract b sub 1 from both sides and you're done. Try these two on your own. And I'll see you tomorrow.